Hey guys, so this is the return of Rubium Maths channel. Today we're just going to go over simple proof, Pythagoras Theorem. Just bust out this square paper because we're going to use a bit of geometry right now. But yeah, what does it say? It says that if you have a right angled triangle with side lengths A, B and C, where C is the longest side, then it satisfies this relation, A squared plus B squared equals C squared. Now, how do we know this? We're going to use two facts in this proof that you'll need to know from geometry. First of all, is that the angle on a straight line is 180 degrees. Second of all, internal angles in a triangle will add up to 180 degrees. So let's get into it. Okay, so what I've just done here is I've copied my triangle here 3 extra times and just put it around and arrange it like this. So as you can see, this is a square here with 3 copies of the triangle. Let me put in the right angles. Okay, so a very important thing here is I don't really know what these angles are. Okay, but it doesn't really matter. What I'm going to do, I'm going to call this angle here theta and this one phi. Like that, so it'll be the same all around. Now, what would I say about theta and phi, the angle? Well, while I don't know what they are individually, because of this, the angles in a triangle add up to 180 degrees. This is just a triangle. So I can write like this. Theta plus phi plus 90 degrees, because we've got a 90-degree angle in the corner, is equal to 180 degrees. But what does this tell me? Well, if this is true, then subtracting 90 degrees from both sides, I can say theta plus phi is equal to 90 degrees. Okay, well, how's that going to help us? Well, look here. I want to figure out what this angle is. Let me just call it epsilon. Okay, but look, it's a straight line. I can use this fact here, that angles on a straight line add up to 180 degrees, to get here epsilon plus theta plus phi is equal to 180 degrees again. What's here? Theta plus phi. That's just 90 degrees. So I can just swap this out. Theta plus phi is 90 degrees. I'll put that in. Epsilon plus 90 degrees is equal to 180 degrees. What does that tell me? Well, if that's true, then I can take away 90 degrees on both sides again to get epsilon is equal to 90 degrees. Okay, well, how's that going to help? Well, I can change this out and see it's a 90-degree angle. Notice that the same applies here, here, and here. So in the center, we have this square with side lengths of C, and it's surrounded by our triangles, A, B, C. Okay, now how that's going to help? What I want to do now is to split this square and find the area in 2 ways. Well, what's one way to do it? Side length, A plus B, because we're just conjoining 2 triangles. And we get A plus B squared as a way to count the area of this shape. How else? We have 4 of these triangles here. And what's the area for a triangle? Half base times height, or half AB in our case. And now we've got these 4 triangles, what in the middle? Well, it's just a square with side length C. So we can have this as C squared. Okay, so now I have A plus B squared is equal to 4 lots of half AB plus C squared. I'll just expand this out. A squared plus 2AB plus B squared is equal to, what's 4 times a half? 2. AB plus c squared. But then look here. 2ab cancels with 2ab, meaning a squared plus b squared equals c squared, just as we wanted. Enjoyed, guys. This is my first video back. I've got new camera equipment and stuff, so let me know any improvements, anything that went bad, you know, anything. Hope you guys enjoyed. Nice little cheeky proof. See you next time.
Oh yeah, it's Rubian.